Okay, in this quick video we're going to look at the idea of electrical energy and electrical power. So let's have a look at this very simple circuit once again, and we're going to look at the current or the charge coming out of this battery. Now those green dots represent individual coulombs of charge. So each of those green dots is 1 coulomb of charge. Okay, and they're moving around the circuit and heading towards our battery. Sorry about that. Heading towards our battery, our globe, and then they will leave the globe and head back to the battery again. Okay, so if we were to put an ammeter in this circuit, which is, remember, like the turnstile that counts the number of coulombs that passes through that turnstile each second, and let's say it's got a reading of 2 amps. So it's counting 2 coulombs per second. So 2 coulombs per second are passing through that ammeter. Okay, and the other bit of information we need is that this battery is a 12-volt battery, and therefore every coulomb that comes out of our battery receives 12 joules of energy. So each of these coulombs receives 12 joules of energy from the battery, and they're traveling around our circuit and delivering this energy to the globe. Okay, so the question we wish to ask is how much energy is arriving at the globe each second? So in order to do that, let's do a little bit of a quick calculation. We know that 2 coulombs of charge are reaching this globe each second. We measured that because that's the current. That's what the current tells us. The ammeter tells us. It's telling us that 2 coulombs of charge are traveling through that little turnstile each second. Okay, so those 2 coulombs of charge are going to get to the globe every second. Also, we know that each coulomb of charge is carrying 12 joules of energy. So if that's the case, then assuming that all of that electrical potential energy that's delivered to the globe is converted into heat and light, so it sort of glows as that energy passes through, so all that energy gets converted to heat and light, then to work out how much energy is actually arriving at this globe every second, then all we need to do is a quick calculation. We know that it's 12 joules per coulomb, 12 joules per coulomb multiplied by the number of coulombs that reach that globe every second. So it's actually 12 times 2, which is 24 joules per coulomb, and then coulomb per second. In other words, we're multiplying these two values together, so 12 times 2 is 24, and joules per coulomb times coulomb per second, the coulombs cancel out, so it gives us joules per second. So 25 joules of energy is being delivered to our globe every second. And so from that we can come up with one relationship or formula that allows us to work out how much energy reaches the globe in 1 second, and that is that amount of energy per second, which we call power, is equal to the current traveling through, or the current entering the globe, which we designate as I, and the energy given to each coulomb of charge as it comes out of that battery or into the globe, which is V. And we actually often say it as P equals VI. So P stands for power, which is the energy delivered per second. So the power or energy delivered to a globe every second or per second is equal to the voltage or the energy per coulomb, times the number of coulombs reaching that globe per second.